Hello and welcome to Code Confidence. Today we are going to look at another LeetCode problem, which is LeetCode 973, k closest points to origin. Let's read the problem statement first. We have an array of points where every point has an x coordinate and a y coordinate. So it's a 2D plane in which we have these points. We are also given an integer k. So our inputs are an array of points, which is a list of lists, and then we have an integer k. We have to return the k closest points to the origin. Alright. How do we decide the distance between the points and origin? So for that we are going to use the Euclidean distance formula. And this is basically the Pythagorean triplet formula, x1 minus x2 square plus y1 minus y2 square. The answer can be returned in any order and it is guaranteed to be unique except for the order. Alright, so we do not need to worry about the sorting part of the points. We just need to figure out what those k closest points are. Alright, let's look at some constraints. So we have 1 is less than equal to k, which is less than equal to points.length, which means that there will at least be one point in the given data and the value of k is upper bounded by the number of points. The total number of points is also less than equal to 10,000. Okay, and the coordinates will also be between minus 10,000 to 10,000. Alright, so with that, let's look at how we should approach solving this problem. The problem mentions k closest. Just like when we discussed the top k, this is also a phrase which suggests that we can use a heap to solve this problem. What we are going to do is we are going to initialize a heap and then fill it with k items and then maintain the k items in this heap. Every time a new point comes, we will see if that should be a part of the heap or it should be ignored. Once we have processed all the points, we will have the k closest points inside our heap. Let's work through an example. Suppose we have these points and that is 1, 1. So there is only one point in the input and the value of k is 1. So we need to find out the closest point to the origin. We will initialize a heap and inside this heap we will keep this point 1, 1, but we will also keep the distance of this point from the origin. Actually, we can keep the square of the distance of this point from the origin. Since all the distances are positive, so instead of keeping the distance, we can keep the square of the distance in our heap. This will make the calculation easier. So we will keep here the square of distance from origin. For 1, 1, this value is 1 squared plus 1 squared, which is 2. This is the tuple that we are going to keep in our heap. And then when we are building our result, we will pop this item from the heap. That will give us 2, 1, 1, and then we will take the point part of this item and that will be the answer. Okay, so let's take a bigger example. Suppose we have points is equal to 3, 3, then 5, minus 1, and then minus 2, 4, and let's say k is equal to 2. So we have to find the two closest points from the origin. We will initialize our heap. Inside this heap, we will keep our points in order of distance. The distance of the first point from origin squared is 18, which is 3 square plus 3 square. Similarly, for this point, it is 26, 5 squared plus minus 1 squared. And for this point, it is 20 minus 2 squared plus 4 squared. All right. When building the heap, we are going to store these items. Now here is the catch. We want to keep the k closest points to the origin. But Python gives us a min heap. So if we pop items from a min heap, then we will lose the closest point first. Okay, and the min heap will give us the k farthest points from the origin. To solve that, we will store the negative of distance squared, so that the item that is farthest away from the origin gets popped out first from the heap. Okay, in other words, what we are building is a max heap. Okay, so now let's see point 3 comma 3, its distance is 18. So what we are going to store in the heap is minus 18, then 3 comma 3. Okay, then we see the point 5 comma minus 1, its distance is 26. So we will store minus 26, then 5 comma minus 1. Now since this value is smaller than this, in the Python implementation, this will become the first item. So our heap will look like minus 26, 5 comma minus 1, and then minus 18, 3 comma 3. Now our heap has attained the maximum size k is equal to 2. So when the next point comes in, we will pop an item out. Okay, now the value is 20, so we will pop this item and put in the next item, which is minus 20, and then minus 2 comma 4. And the other item will be minus 18 comma 3 comma 3. Okay, this is what our heap looks like. Now we have run through all the points. So the next part is to extract these items. When we extract, we will only keep the point part. And so our solution will have minus 2 comma 4 and then 3 comma 3. That is our solution. Okay, let's go to LeetCode and see how we can code this. Okay, so we saw that we are going to use a heap to solve this problem. Specifically, we are going to use a max heap and we are going to store the negative of distance squared in our heap. So we will start by importing the heap queue module. Now we will process all the points. So for point in points, let's first find the distance squared is equal to, so that will be 0.0, which is the x part, squared plus 0.1 squared. Now we push this into our heap. So heap queue dot heap push. Now we need to save it in a heap. So let's define a heap here. Oops. So we add that to the heap. And what are we saving in our heap? We are saving the negative of distance squared followed by the point. We can write it like this. Okay. Now, once the length of the heap reaches k, then we perform the replacements. So if len of heap is greater than k, then we need to start popping the items from the top. So heap queue dot heap pop heap. Once we have processed all the points, then we start building our result. So we can say result is equal to an empty array first, and then we will say for I in range k, we only need to concern ourselves with the point and not with the square of the distance. So we can say underscore comma point is equal to heap q dot heap pop heap. Then we can append this to the result. Finally, when we have processed the heap, we can return the result. So this is our code. Let's look at it once. We are importing the heap, creating a empty heap, then processing through all the points. We first calculate the distance from the origin and then we push it onto the heap. The item that we are pushing is negative of the square distance and the point. If the heap reaches length k, then we start popping from the heap. And in this part of the code, we are building the result. Alright, so let's run and see if the code works. And great, we have an accepted for the test cases. So let's submit this to see if it works on all the test cases. So if I submit here, we have an accepted solution. So that's great. This is our solution to the k closest points. Let's talk about the time complexity of our solution. Here we are running through the points. So if length of the points array is n, then this part is on. We are calculating a distance in constant time. Then we are pushing onto the heap. The size of the heap is being kept at k maximum. So this push operation is log of k, and inside the loop which is running n times. So the time complexity then becomes order of n log k. What about the space complexity? Well, we are using a heap that can go to a maximum of size k, and so the space complexity will be order of k. Alright, so that's it for this problem. I'll see you another time.